Okay. Good afternoon. I'm Haoyan Liu from Hohai University, and I will introduce our recent study about the long-lived tropical cyclone Freddy over the South India Ocean this year. So the first is the overview of Freddy. So let me look the animation. So this is Freddy, and this is another storm named Dingani. Storm Freddy formed on the 6th of February, and finally dissipated on March 17th this year. So its lifetime is 75 days. Become the most long-lived tropical cyclone by now. So before the formation of Freddy, the most long-lived tropical cyclone is Hurricane Joy in 1994. So this is the track and intensity of Freddy. During the lifetime of Freddy, its maximum intensity is 71 meter per second, and its experiments 3 times of rapid intensification and 3 times of making landfall from Madagascar Island and South Africa, and 1 time of regeneration, and also the 6-day interaction with Storm Dingani. So this is the visible satellite images of Freddy. So it's we can see that it's the size of Freddy is not large, and its diameter is about 700 kilometers, comparable to Hurricane Irma in 2017. During the movement of Freddy, its environment featured with a weak vertical wind shear and warm SST, while its atmosphere is relatively drier than other basins. This is the black curve is this along this track. So as forecast agency mainly focus on 5-day TC forecast. So little is known about the accuracy of TC forecast for exceeding 1 week. So we focused on the predictability of Freddy during exceeding 2 weeks through the South India Ocean. So we use the iwtrc data as the observed in track and intensity of Freddy, and we also use the GFS data and the ERA5 data for the analysis of environmental fields, and we also use the GFS data to drive the regional simulations. So to evaluate the TC forecast of NWP models, we use the TG data from 5th to 24th February, and the ensemble forecast from five centers, and the member size and the forecast period are shown in this table. So there are exceeding 7,000 ensemble forecasts. Now, this is the forecast track of the TG data. So you can see before 17th of February, the forecast track were more southward than the best track data, and its translational speed was slower than the observation. So it's difficult for the NWP models to forecast its track, and then it's the intensity, its forecast intensity. All the global forecasts underestimated the intensity of Freddy. So all the forecasts from each day. Now it's this is the track error and intensity error. So the track error increase with time, and the spread is this blue curves is smaller than the RMSE. This means the forecasts are concentrated and the forecast is inaccurate. Well, for the intensity forecast, the intensity errors was small when Friday was weak, and the errors was large when Friday was intense. So, but the spread was also largely smaller than the RMSE. So this means the global forecast cannot capture the intensity change of Friday. So we can conclude that the global NWP models it's difficult for the global NWP models to forecast Friday for exceeding 1 week. So we conduct the composite analysis. This figure is the difference of the 25 forecasts with the smallest track error, and the 25 forecasts with the largest track error. So the difference is for the sea level pressure, and the dots means the difference exceeding 99% confidence level. So you can see that there are 3 regions of the difference. One is Friday, the blue colors, Friday, and the storm Dingani. And also there is another region is the subtropical high named Masculine High. So you can see in the good forecast, the position of Friday and Dingani located more eastern or southeastern, and the Masculine High was stronger. So to quantify the influence of Masculine High on the predictability of Friday, so we conduct the linear regression function of the Masculine High index bias and the track errors. So the Masculine High index is the average of the subtropical region, and the bias means the global forecast minus GFS reanalysis. So the function is like this. It shows a negative relationship between the Masculine High index bias and the track errors. This means that when the Masculine High was weak, the track error was larger. As the Masculine High can provide the easterly steering flow for the movement of Friday. So if the Masculine High was weak, the storm Friday would move more southward towards the polar, and its translational speed was also smaller. So the next is the storm Dingani, or the interaction between Dingani and Friday. We also calculate the linear regression between the track hours of both TCs. So the track hour increase of the track hour of the both TCs increase at the same time. And furthermore, we found that the track hour of Dingani was caused by the eastern position and northern position. So that means in bad forecast, Dingani was located closer to Friday. So as a result, the clockwise circulation of Dingani would move Friday. Would make Friday move more southward and toward polar. The last is Friday itself. As the global NWP model underestimated the intensity of Friday, so we further examined the vortex size. So we defined the vortex size as the radius of 8 meters per second. So also the linear regression was shown in this figure. So you can see that when the R08 was around 400 to 600, the track error was smaller. So that means the forecast size of Friday should not be too large or too small. We also use the Wolf model to verify the above the above factors. So the model setup and experiment design was shown in this figure. So in the control run, it's the red curves. The Friday moved more southward and slowly, and also prematurely dissipated. So if when the storm Dingani was removed from at the initial time, the track was better, also as well as the intensity was better. But Friday also prematurely dissipated. And when we expand the size of the vortex size of Friday to large size at initial time, it's this orange yellow curve. The Friday moved more southward towards polar, and also prematurely disappeared. But in this run, it's the SN run. We use the large scale spectral nudging to force the horizontal winds with wavelengths larger than 1,000 kilometers. All the track and intensity was better. This is because the large scale steering flow of Friday was close to the was accurate. The masculine high, its pattern and strength was close to the GFS analysis, and the location of Dingani was also close to the best track data. But while in other experiments, the steering flow was inaccurate. So okay, I will give a summary. So it's difficult for NWP models and also the high resolution reasonable model to predict Friday for exceeding 1 week. The limited predictability was related to the underestimated masculine high and the more northeastern position of storm Dingani, and also the inaccurate forecast size of Friday, whether too large or too small, also contributed to the large track errors. So it's worth considering how to improve forecast for long life tropical cyclones. Thank you.
Thank you very much. I'd like to take some questions or comments from audience. No? Please enjoy the discussion. Yeah. Please go ahead, Professor Emmanuel.
Just very briefly, it's clear that the models had a very hard time with the intensity. But on the other hand, there's no reconnaissance of tropical cyclones in that part of the world. And I caution you against accepting the best track intensity as the truth. It could be very far off, judging from previous studies of this. So I think we have to bear that in mind. It's another challenge we have when we're doing intensity is what's the truth? And in that part of the world, we could be pretty far off.
Thank you. Thank you.
Any other comments or questions? Okay. Yeah. Thank you very much. So
in your experiment, the result of spectral nudging showed a very good track result.
Yes, you mean the spectral nudging?
The blue one. And I want. And large Freddy wasn't done, I guess, for the without doing spectral nudging. So my question is, how if you have done the spectral nudging experiment with a larger Freddy, then you could also identify to some extent what the size of Freddy mattered, even if even if you have a correct the environmental means. So have you done that?
You mean the
Large Freddy.
initial condition, and you also use the last. Sorry, we don't conduct this another experiments for this, but we can check it.
Yeah.
Thank you.
So thank you very much. We want to move on to the next presenter. So thank you very much.